first image shows the truth table I have drawn for a 2x1 multiplexer that includes the intermediate steps. The intermediate steps are S inverted, an AND gate between A and the inversion of S, an AND gate between B and S, and the ultimate OR gate that results in Z. Our first BJT circuit is a NOT gate where A is low and Z is correctly returned as high. When A is high, Z will be returned as low. Due to the limitations of the circuit, the voltage of Z is not entirely zero, but it can be assumed to be zero. Our next transistor circuit is an AND gate with A high and B high. This returns as we see Z to be high. Our next example is when A is high and B is low for an AND gate. In this case, Z is returned as low. As is the case with all AND gates, if one of the inputs is low, then the output will be low. Finally, we have a BJT circuit to simulate an OR gate. In this, A is high and B is low, and Z is correctly returned as high. In our final example, both A and B are low, and Z is returned as low. That is because in an OR gate, if any of the inputs are high, then Z will be high. So in order to get an output of low, both inputs must be low. Now, I've created a 2-to-1 multiplexer using Circuit Labs. This is composed of two AND components, an OR gate, and one inverter. I have attached three examples of S, A, and B varying, and the Z result being the correct Z that we saw in the first pre-lab question. So here is my 2-to-1 multiplexer circuit I created in Tinkercad using the breadboard and the series of gates and wires. As you can see, I can move around the green wire, the yellow wire, and the blue wire, which represent S, the selection A and B. The orange wires represent intermediate steps, and by connecting them to the power and ground, that makes a high or low reading, which in turn changes our Z value and decides whether the LED is illuminated or not. This all coincides with the first part of the lab. We saw every solution matches thus far, proving that this works. So this circuit setup I've drawn is a series of three 2x1 multiplexers that combine to give a single 4x1 multiplexer. In order to accurately do that, we need 6 inputs. We need 2 selector inputs and then 4 A, B, C, and D respectively inputs that will represent the 4 possible results for a 4x1 multiplexer. So with how it's set up now, any of these 4 can be voltage sources. They'd be 5 volts for high, 0 volts for low. So for example, if all A, B, C, and D were high, it doesn't matter what the selectors are, the return will always be high. The first set of this, the first stage is where the first of the 2 selectors goes through, and the second stage is where the second goes through. This is to cull basically our options so that we can get all 4 A, B, C, and D possibilities into one final Z result, which will be returned in the LED at the bottom. The 2 intermediate LEDs are to show whether it would be a high or low passing through after each intermediary step. So for example, let's say S0 is 0, S1 is 1, A is 1, B is 0, C is 0, and D is 1, for instance. So in our first one in the top right, S0 would be 0, which means we would go with the A result, which is 1, and the LED would be illuminated. For the next one, S0 remains 0, which means we would go with C, which is 0, so the LED would not be illuminated. So now we have 1 for AB and 0 for CD. S1, we said, is 1, which means we will go with the CD result, which will result in a Z of 0, and our final LED will not be illuminated. This simulates the 4x1 multiplexer using just 2x1 multiplexers. So for the first part of this lab, I have wired up the Tinkercad creation that we made in the third question of the pre-lab. AKA, I have created a 2x1 multiplexer using the gates we have provided, the breadboard, the Arduino, and a series of wires. I do have more power and ground wires than I do red and black colors, so I've additionally used white to represent power and gray to represent ground. The only instance those occur is on the very far end of the board. I have also used the color orange to represent all the intermediate steps in between the gates. So for example, S inverted and A, S and B, and then the ultimate OR function are all represented with the orange intermediate steps. If we take a look at this, you can see it matches the Tinkercad creation. If it looks confusing, I would strongly recommend referring to the Tinkercad creation. It'll be much easier to see. So in this instance, I have manually wired all our inputs to either ground or the high setting, which would be 5 volts. So just what I have currently, we have the green selector wires are high, we have the yellow A input is low, and we have the blue B input is high. Now, based on our truth table, we would expect our LED, which is right here, to be high when this is plugged in. So let's power it on. Taking a still here to show that our LED is on in the high position, which will verify our truth table. We can test all the other inputs possible and we will see that they are verified as well, but for time's sake, we're just going to stick with this one input and move on to the next question. So for the final part of this lab experiment, I connected inputs A and B to Arduino inputs, and in the Arduino code, I made it so that when the selector is in the high position or the low position, the LED flash will change accordingly. The reason is this is a fundamental part of a 2x1 multiplexer where, as it is currently, the selector, these green wires right here, are high, which means B is the predominant one passing through, and the frequency is 0.5 hertz. If I were to make these low, we would make A dominant. A has a frequency of 10 hertz. We can see it takes my some of the wire leads have a bit of trouble working, and oh, there we go. We can see it flashing at 10 hertz. Now I'll set it back to 0.5 hertz, just like that. Now, so one final thing I wanted to address is you can see I have 4 of these gates on here. And the reason I did this was because I know these are 2 AND gates. That's redundant. You can do 2 different, you can do multiple different AND gates on the same one of these pieces, but it helped me to better visualize multiple AND gates by doing them in this sequence like this, so it looks like there's some sort of method to what's going on here. And that was reflected in everything I've done, from Tinkercad to the actual circuit I drew. I did 2 of these just to represent AND gates. In the future, obviously, I'll just do multiple AND gates on one, but seeing as this is lab 1, I figured it was helpful. Thank you, and have a nice day.